Hello, and welcome to Screaming in the Cloud, with your host, Chief Cloud Economist at the Duckbill Group, Corey Quinn. This weekly show features conversations with people doing interesting work in the world of cloud, thoughtful commentary on the state of the technical world, and ridiculous titles for which Corey refuses to apologize. This is Screaming in the Cloud.
This video is sponsored by Teleport.
Supply chain attacks and other application exploits are growing faster than ever. Why is that? Well, here's an industry secret for you. Everyone is secretly really bad at their jobs a disturbing proportion of the time. A big, considerably more fixable reason is because vulnerable CI/CD systems, service accounts, and microservices all don't have an identity. No identity means no authentication and authorization when these services are used, which in turn tends to serve to maximize the blast radius of an attack. And that's why Teleport created Machine ID. Machine ID delivers identity-based access and audit for infrastructure resources like servers and databases, CI/CD automation, service accounts, and custom code and applications such as microservices. By consolidating identity-based credentials for engineers and the applications they write, Teleport closes the identity loophole that enables compromised infrastructure and code to be used in cyber attacks. People will still suck at our jobs, but Machine ID helps our security posture suck significantly less. Smash the link to learn more, along with the like and subscribe buttons while you're poking around down there.
Welcome to Screaming in the Cloud. I'm Corey Quinn. One of the interesting things about hanging out in the cloud ecosystem as long as I have, and as, I guess, closely tied to Amazon as I have been, is that you learn that you never quite are able to pronounce things the way that the people pronounce them internally. In-house pronunciations are always a thing. My guest today is Liz Rice, the Chief Open Source Officer at Isovalent, and they're responsible for, among other things, the Cilium open source project, which is around eBPF, which I can only assume is internally pronounced as Ehbehpf. Liz, thank you for joining me today and suffering my pronunciation slings and arrows.
I have never heard Ehbehpf before, but I may have to adopt it. That's great.
You have to. You also are currently in a term that is winding down, if I'm not misunderstanding. You were the co-chair of KubeCon and Cloud Native Con at the CNCF, and you are also currently on the technical oversight committee for the foundation.
Yeah. I'm currently the chair, in fact, of the Technical Oversight Committee. And
now that Amazon has joined, I assumed that they had taken their horrible pronunciation habits, like calling AMIs AMIs and whatnot, and started spreading them throughout the ecosystem with wild abandon.
Are we going to have to start calling CNCF or something?
Exactly. They're very frugal, by which I mean they never buy a vowel. So yeah, it tends to be an ongoing challenge. Now, joking and on the rest aside, let's start, I guess, at the macro view. The CNCF does an awful lot of stuff, where if you look at the CNCF landscape, for example, like I think some of my jokes on the internet go a bit too far, but you look at this thing, and last time I checked, there were something like 400 or 500 different players in various spaces. And it's a very useful diagram. Don't get me wrong by any stretch of the imagination, but it also is one of those things that is so staggeringly vast that, well, I've got to level with you on this one. Given my old ancient sysadmin roots, it's the hell with it. I'm going to run some VMs in a 3-tiered architecture, just like grandma and grandpa used to do, and call it good. Not really how the industry has evolved, but it's overwhelming.
That might be the right solution for your use case. So, don't knock it if it works.
Yeah. If it's a terrible architecture and it works, is it really that terrible of an architecture? One wonders.
Exactly. Yeah. I mean, I'm definitely not one of those people who thinks, every solution has the same, is solved by the same hammer. All problems are not the same nail. So, I am a big fan of a lot of the CNCF projects, but that doesn't mean to say I think those are the only ways to deploy software. There are plenty of, things like Lambda are a really great example of something that's super useful and very applicable for lots of, applications and for lots of development teams. Not necessarily the right solution for everything. And for other people, they need all the bells and whistles that something like Kubernetes gives them. horses for courses.
It's very easy for me to make fun of just about any company or service or product. But the thing that always that makes me set that aside and get down to brass tacks has been, okay, great. You can build whatever you want. You can tell whatever glorious marketing narrative you wish to craft. But let's talk to a real customer. Because once we do that, then if you're solving a problem that someone is having in the wild, okay, now it's no longer just this theoretical exercise in PowerPoint. Now let's actually figure out how things work when the rubber meets the road. So let's start, I guess, with, I'll leave it to you. Isovalent are the creators of the Cilium eBPF-based networking project.
Yeah.
And eBPF is the part of that I think I'm the most familiar with, having heard the term. Would you rather start on the company side or on the eBPF side?
Oh, I don't mind. Why don't we start with eBPF? Yeah.
Cool. So easy, ridiculous question. I know that it's extremely important because Brendan Gregg periodically gets on stage and tells amazing stories about this. The last time he did stuff like that, I went stumbling down into the rabbit hole of dtrace, and I have never fully regretted doing that, nor completely forgiven him. What is eBPF?
So it stands for Extended Berkeley Packet Filter, and we can pretty much just throw away those words because it's not terribly helpful. What eBPF allows you to do is to run custom programs inside the kernel. So we can trigger these programs to run maybe because a network packet arrived, or because a particular function within the kernel has been called, or a trace point has been hit. There are tons of places you can attach these programs to, or events you can attach programs to. And when that event happens, you can run your custom code. And that can change the behavior of the kernel, which is, great power and great responsibility. But incredibly powerful. So Brendan, for example, has done a ton of really great pioneering work showing how you can attach these eBPF programs to events, use that to collect metrics, and lo and behold, you have amazing visibility into what's happening in your system. And he's built tons of different tools for, observing everything from, memory use to file opens to, there's just endless dozens and dozens of tools that Brendan, I think, was probably the first to build. And now there's sort of new generations of eBPF-based tooling that are kind of taking that legacy, turning them into maybe more, user-friendly interfaces, with GUIs and hooking them up to metrics platforms. And in the case of Cilium, using it for networking and hooking it into Kubernetes identities and making the information about network flows meaningful in the context of Kubernetes, where things like IP addresses are ephemeral and not very useful for very long. I mean, they just change at any
I guess
moment.
I'm trying to figure out what part of the stack this winds up applying to, because you talk about, but at least to my mind, it sounds like a few different levels all at once. You talk about running code inside of the kernel, which is pretty close to the hardware. It's, oh, great. It's adventures in assembly is almost what I'm hearing here. But then you also talk about using this with GUIs, for example, and operating on individual packets to run custom programs. When you talk about running custom programs, are we talking things that are a bit closer to, modify this one field of that packet and then call it good? Or are you talking, now we launch Microsoft Word?
Much more the former category. So let's inspect this packet and maybe change it a bit, or send it to a different, maybe it was going to go to one interface, but we're going to send it to a different interface. Maybe we're going to modify that packet. Maybe we're going to throw the packet on the floor because we don't. And there's some really great security use cases for inspecting packets and saying, this is a bad packet. I do not want to see this packet. I'm just going to discard it. And there's some what they call packet of death vulnerabilities that have been mitigated in that way. And the real beauty of it is you just load these programs dynamically, so you can change the kernel on the fly and affect the behavior just immediately, and affect, if there are processes already running, they get instrumented immediately. So maybe you run an BPF program to spot when a file's opened. new processes, existing processes, containerized processes, it doesn't matter. They'll all be detected by your program if it's observing file open events. And that's
Is this primarily used from a security perspective? Is it used for, effectively, what are the common use cases for something like this?
There's three main buckets, I would say: networking, observability, and security. And in Cilium, we're kind of involved in some aspects of all those three things. And there are plenty of other projects that are also focusing on one or other of those aspects.
This is where when I guess the challenge I run into of the whole CNCF landscape is. It's like, I think the danger is, when I started down this path that I'm on now, I realized that, I have to learn what all the different AWS services do. This was widely regarded as a mistake. They are not Pokemon. I do not need to catch them all. The CNCF landscape applies very similarly in that respect. What is the real world problem space for which eBPF or things like Cilium that leverage eBPF, because eBPF does sound fairly low level, that turn this into something that solves a problem people have? In other words, what is the tool? What is the problem that Cilium should be the go-to answer for when someone says, I have this thing that hurts?
So at one level, Cilium is a networking solution. So it's a Kubernetes CNI. You plug it in to provide connectivity between your applications that are running in pods. Those pods have to talk to each other somehow, and Cilium will connect those pods together for you in a very efficient way. One of the really interesting things about eBPF for networking is we can bypass some of the networking stack. So if we are running in containers, we're running our applications in containers in pods, and those pods usually will have their own networking namespace. And that means they've got their own networking stack. So a packet that arrives on your machine has to go through the networking stack on that host machine, go across a virtual interface into your pod, and then go through the networking stack in that pod. And that's kind of inefficient. But with eBPF, we can look at the packet the moment it's come into the kernel. In fact, in some cases, if you have the right networking interfaces, you can do it while it's still on the network interface card. So you look at that packet and say, well, I know what pod that's destined for. I can just send it straight there. I don't have to go through the whole networking stack in the kernel, because I already know exactly where it's going. And that has some real performance improvements.
That makes sense. In my explorations, we'll call it, with Kubernetes, it feels like it's the universe, at least the time I went looking into it, was step one. Here's how to wind up launching Kubernetes to run a blog, which is a bit like using a chainsaw to wind up cutting a sandwich. Okay, massively overpowered, but I get the basic idea. Like, okay, what's project step two? It's like, oh, great, go build Google. Okay, great. It feels like there are some intermediary steps that have been sort of glossed over here. And at the small scale that I kicked the tires on, things like networking performance never even entered the equation. It was more about get the thing up and running. But yeah, at scale, when you start seeing huge numbers of containers being orchestrated across a wide variety of hosts, that has serious repercussions and explains an awful lot. Is this the sort of thing that gets leveraged by cloud providers themselves? Is it something that gets built in mostly on-prem environments, or is it something that rides in almost user land for most of these use cases that customers go into bringing to those environments?
Yeah, it's
I'm sorry,
sort of
users,
all of
not
the
customers.
above.
I'm too used to the Amazonian phrasing of everyone is a customer. No, they are users in an open source project.
Yeah, so if you're using GKE, the GKE data plane V2 is using Cilium. Alibaba Cloud uses Cilium. AWS is using Cilium for EKS Anywhere. So, these are really, I think, great signals that it's super scalable. And it's also not just about the connectivity, but also about being able to see your network flows and debug them, because like you say, that day one your blog is up and running, and day two you've got some DNS issue that you need to debug, and how are you going to do that? And because Cilium is it's working with Kubernetes, so it knows about the individual pods, and it's aware of the IP addresses for those pods, and it can map those to, what's the pod, what service is that pod involved with. And we have a component of Cilium called Hubble that gives you the flows, the network flows between services. So, we've probably all seen diagrams showing service A talking to service B, service C, some external connectivity. And Hubble can show you those flows between services and the outside world, regardless of how the IP addresses may be changing underneath you, and kind of aggregating network flows into those services that make sense to a human who's looking at a Kubernetes deployment.
Running gag that I've had is that one of the drawbacks and appeals of Kubernetes all at once is that it lets you cosplay as a cloud provider, even if you don't happen to work for one of them. And it's a bit of there's a bit of truth to it, but let's be serious here. Despite what a lot of the cloud providers would wish us to believe via a bunch of marketing, there's a tremendous number of data center environments out there, hybrid environments, and companies that are in those environments are not somehow laggards or left behind technologically or struggling to digitally transform. Believe it or not, I know it's not the common narrative, but large companies generally don't employ people who lack critical thinking skills and strategic insight. There's usually a reason that things are the way that they are. And when you don't understand that, my default approach is that, there's context that gets missing. So I want to preface this with the idea that there's nothing wrong in those environments. But in a purely cloud native environment, which means that I'm very proud about having no single points of failure as I have everything routing to a single credit card that pays the cloud providers. Great. What is the story for Cilium if I'm using effectively the managed Kubernetes options that name any cloud provider will provide for me these days? Is it at that point no longer for me? Or is it something that instead, I guess, expresses itself in ways I'm not seeing yet?
Yeah, so I think as an open source project, and it is the only CNI that's at incubation level or beyond. So, it's a CNCF supported networking solution. You can use it out of the box. You can use it for your tiny blog application. If you decided to run that on Kubernetes, you can do so. I think things start to get much more interesting, at scale. That continuum between, there are people purely on managed services. There are people who are purely in the cloud. Hybrid cloud is a real thing, and there are plenty of businesses who have good reasons to have some things in their own data centers, some things in the public cloud, things distributed around the world, so they need connectivity between those. And Cilium will solve a lot of those problems for you in the open source, but also if you're, telco scale and you have things like BGP networks between your data centers, then that's where the paid versions of Cilium, the enterprise versions of Cilium, can help you out. And, as Isovalent, that's our business model, to have like a very, we fully support the, or we contribute a lot of resources into the open source Cilium, and we want that to be the best networking solution for anybody. But if you are an enterprise who wants those extra bells and whistles and the kind of scale that, a telco or a massive retailer or a large media organization or, name your vertical, then we have solutions for that as well. And I think that's one of the really interesting things about the eBPF side of it, is that, we're not bound to just Kubernetes. We run in the kernel, and it just so happens that we have that Kubernetes interface for allocating IP addresses to endpoints that happen to be pods. But
so back to my crappy pile of VMs, because the hell with all this newfangled container nonsense, I can still benefit from something like Cilium.
Exactly, yeah. And there's plenty of people using it for, just load balancing, which, why not have an eBPF based high performance load balancer?
Hang on, that's taking me a second to work my way through. What is the programming language for eBPF? Is it something custom?
Right. So when you load your BPF program into the kernel, it's in the form of eBPF bytecode. There are people who write eBPF bytecode by hand. I am not one of those people.
There are people who used to be able to write setmail configs without running it through the M4 preprocessor, and I don't understand those people either.
So our choices are, it has to be a language that can be compiled into that bytecode. And at the moment, there are two options, C and more recently Rust. So the C code, I'm much more familiar with writing BPF code in C. It's slightly limited. So because these BPF programs have to be safe to run, they go through a verification process which checks that you're not going to crash the kernel, that you're not going to end up in some hard loop and basically make your machine completely unresponsive. We also have to know that BPF programs won't, they'll only access memory that they're supposed to and that they can't mess up, other processes. So there's this BPF verification step that checks, for example, that you always check that a pointer isn't nil before you dereference it. And if you try and use a pointer in your C code, it might compile perfectly, but when you come to load it into the program, it gets rejected. So when you come to load it into the kernel, it gets rejected because you forgot to check that it was non-null.
You try and run it, the whole thing seg faults, you see the word fault there, and I guess blameless just went out the window there.
Well, this is the thing, you cannot seg fault in the kernel, or at least if that's
you say that, but I'm very bad with computers. Let's be clear here. There's always a way to misuse things horribly enough.
It's a challenge. It's pretty easy to seg fault if you're writing a kernel module. But maybe we should put that out as a challenge for the listener to try to write something that crashes the kernel from within eBPF, because there's a lot of
right now the blood just drained from anyone who's listening in the kernel space or the InfoSec space.
Exactly.
I imagine
some of my colleagues at Isovalent are thinking, "Oh no, what she brought on?
What have you done?" Please correct me if I'm misunderstanding this. So eBPF is a very low-level tool that requires certain amounts of braining in order to use appropriately. That can be a heavy lift for a lot of us who don't live in those spaces. Cilium distills this down into something that is a lot more usable and understandable for folks. And then beyond that, you wind up with Isovalent that winds up effectively productizing and packaging this into something that becomes a lot more closer to turnkey. Is that directionally accurate?
Yes, I would say that's true. And there are also some other intermediate steps like the CLI tools that Brendan Gregg did, where you can run, a CLI is still fairly low level, but it's not as low level as writing the eBPF code yourself. And you can be quite in-depth, if you know what, if you know what things you want to observe in the kernel, you don't necessarily have to know how to write the eBPF code to do it, but you've got these fairly low-level tools to do it. You are absolutely right that very few people, a very tiny proportion of people will need to write their own BPF code to run in the kernel. It's definitely quite.
It's moved below the surface level of awareness, the same way that most of us don't need to know how to compile our own kernel in this day and age. A few people very much do, but because of their hard work, the rest of us do not.
Exactly. And for most of us, we just take the kernel for granted. Most people writing applications, it doesn't really matter if they're just using abstractions that do things like open files for them or send, create network connections or write messages to the screen. You don't need to know exactly how that's accomplished through the kernel unless you want to get into the details of how to, observe it with eBPF or something like that.
I am much happier not knowing some of those details. I did a deep dive once into Linux system kernel internals based on an incredibly well-written, but also obnoxiously/suspiciously thick O'Reilly book, Linux systems internals. And it was it was one of those like halfway through, can I please be excused? My brain is full. It's one of those things that I don't use most of it on a day-to-day basis, but it solidified my understanding of what the computer is actually doing in a way that I will always be grateful for.
And there are tens of millions of lines of code in the Linux kernel. So, anyone who can internalize any of that is basically a superhero.
I have nothing but respect for people who can pull that off.
Yeah.
You, in your day job, quote unquote, which is sort of a weird thing to say, given that you are working at an open source company. In fact, you are the chief open source officer. So what you're doing in the community, what you're exploring on the open source project side of things, it is all interrelated. I tend to have trouble myself figuring out where my job starts and stops most weeks. I'm sympathetic to it. What I guess inspired you folks to launch a company that is, we're going to be in the open source space, especially during a time when there's been a lot of pushback in some respects about the evolution of open source and the rise of large cloud providers, where is open source a viable strategy or a tactic to get to an outcome that is pleasing for all parties?
So I wasn't there at the beginning for the Isovalent journey. And Cilium's been around for 5 or 6 years now at this point. I very strongly believe in open source as a effective way of developing technology, good technology, and getting really good feedback and kind of optimizing the speed at which you can innovate. But I think it's very important that businesses don't kind of think, you could. If you're giving away your code, you cannot also sell your code. You have to have some other thing that adds value. Maybe that's some extra code, like in the Isovalent example, the enterprise-related enhancements that we have that aren't part of the open source distribution. There's plenty of other ways that people can add value to open source. They can do training, they can do managed services. There's all sorts of different ways. Support was the classic example. But I think it's extremely important that businesses have or don't just expect that, I can write a bunch of open source code and somehow magically through building up a whole load of users, I will find
a bunch of nerds will build my product for me on nights and weekends. That's a bit of an outmoded way of thinking about these things.
Yeah, exactly. And I think it's not like everybody has perfect, ability to predict the future, and you might.
No, and I have a lot of sympathy for companies who originally started with the idea of, we are the product, we're the project leads, we know this code the best, therefore we are the best people in the world to run this as a service. The rise of the hyperscale cloud providers has called that into significant question. And I feel for them, because it's difficult to completely pivot your business model when you're already a publicly traded company. That's a very fraught and challenging thing to do. It means that you're left with a bunch of options, none of them great.
Yeah.
Cilium my apologies. Cilium as a project is not that old, neither is Isovalent, but it's new enough in the iterative process that you were able to avoid that particular pitfall. Instead, you're looking at, in some level, making this understandable and useful to humans, almost to the point where it disappears from their level of awareness that they need to think about. There's huge value in something like that. Do you think that there is a future in which projects and companies built upon projects that follow this model are similarly going to be having challenges with hyperscale cloud providers or other emergent threats to the ecosystem? I'm sorry, threat is an unfair and unkind word here, but the changes to the ecosystem as we see the world evolving in ways that most of us did not foresee.
Yeah, we've certainly seen some examples in the last year or two, I guess, of companies that maybe didn't anticipate, and who necessarily has the crystal ball to anticipate how cloud providers might use their software. And I think in some cases, the cloud providers have not always been the most generous or most community minded in their approach to to how they've done that. But I think for a company like Isovalent, our strong point is talent. We have it. It would be extremely rare to find the level of expertise in, what is a pretty specialized area. The people at Isovalent who are working on Cilium are also working on eBPF itself. And that level of expertise is, I think, pretty unrivaled. So we're in such a new space with eBPF. We've only in the last year or so got to the point where pretty much everyone is running a kernel that's new enough to use eBPF. Startups do have a kind of, agility that I think is, gives them an advantage, which I hope we'll be able to capitalize on. I think sometimes when businesses get upset about their code being used, they probably could have anticipated it. If it's open source, people will use your software, and you have to think.
What do you mean? You're using the thing we gave away for free, and you're not paying us to use it?
Yeah.
Did you hear what you just said out loud? Some of this was predictable. Let's be fair.
Yeah, and I think you really have to, as a responsible business, think about, well, what does happen if they use all the open source code? Is that a problem? And as far as we're concerned, everybody using Cilium is a fantastic thing. We fully welcome everyone using Cilium as their data plane, because there's so many. The vast majority of them would use that open source code, and that would be great. But there will be people who need the extra features and the expertise that I think we're in a unique position to provide. So, I joined Isovalent just about a year ago, and I did that because I believe in the technology. I believe in the company. I believe in the foundations that it has in open source. It's a very much an open source first organization, which I love, and that resonates with me and how I think we can be successful. So I don't have that crystal ball. I hope I'm right. We'll find out. We should do this again in a couple of years and see how that's panning out.
I'll book out the date now. Looking back at our conversation just now, you talked about open source and business strategy and how that's going to be evolving. We talked about the company. We talked about an incredibly in-depth technical product that honestly goes significantly beyond my current level of technical awareness. And at no point in any of those aspects of the conversation did you talk about it in a way that I did not understand, nor did you come off in any way as condescending. In fact, you wrote an O'Reilly book on container security that's written very much the same way. How did you learn to do that? Because it is, frankly, an incredibly rare skill.
Oh, thank you. Yeah, I think I have never been a fan of jargon. I've never liked it when people, use a complicated acronym or really early days in my career, there was, a bit of a running joke about how everything was TLAs. And you think, well, I understand why we use an acronym to shorten things, but I don't think we need to assume that everybody knows what everything stands for. Why can't we explain things in simple language? Why can't we, just use ordinary terms? And I've found that really resonates. If I'm doing a presentation or if I'm writing something, using straightforward language and explaining things, making sure that people understand the kind of fundamentals that I'm going to build my explanation on. I just think that it results in people understanding. And that's my whole point. I'm not trying to explain something to, my goal is that they understand it, not that they've been blown away by some kind of magic. I want them to go away going, now I understand how this bit fits with that bit, or how this works. Because
the reason I bring it up is that it's an incredibly undervalued skill, because when people see it, they don't often recognize it for what it is. Because when people don't have that skill, which is common, people just write it off as, oh, that person's a bad communicator, which I think is a little unfair. It's being able to explain complex things simply is one of the most valuable yet undervalued skills that I've found in this entire space.
Yeah, I think people sometimes have this sort of wrong idea that vocabulary and complicated terms are somehow inherently smarter, and that if you use complicated words, you sound smarter. And I just don't think that's accessible, and I don't think it's true. And sometimes I find myself listening to someone and they're using, complicated terms or analogies that are really obscure. And I'm thinking, but could you explain that to me in words of one syllable? I don't think you could. I think you're hiding, not you.
No, yeah, that's fair. I'll take the accusation as legally as I can get it.
But I think people hide behind, complex words because they don't really understand them sometimes. And yeah, I would rather people understood what I'm saying.
To me, I've done it through conference talks, but the way I generally learn things is by building something with them. But the way I really learn to understand something is I give a conference talk on it, because, okay, great, I can now explain Git, which is one of my early technical talks, to folks who built Git. Great. Now, how about I explain it to someone who is not immersed in the space whatsoever?
Yeah.
And if I can make it that accessible, great, then I've succeeded. It's a lot harder than it looks.
Yeah, exactly. And I think if I'm building talks, one of the reasons why I enjoy building a talk is because I know I've got a pretty good understanding of this, but by the time I've got this talk nailed, I will know this. I might have forgotten it in 6 months' time, but while I'm giving that talk, I will have a really good understanding of that, because the way I want to put together a talk, I want to understand. I don't want to put anything in a talk that I don't feel I could explain. And that means I have to understand how it works.
It's funny, this whole don't give talks about things you don't understand. Seems like this really nouveau concept, but here we are. We're working with it.
I have committed to doing talks that I don't fully understand, knowing that, with the confidence that I can find out between.
I believe that's called a forcing function. It's one of those very high risk stories. Like, either I'm going to learn this in the next 3 months, or else I am going to have some serious egg on my face.
Yeah, exactly. Definitely forcing function.
I really want to thank you for taking so much time to speak with me today. If people want to learn more, where can they find you?
So I am online pretty much everywhere as Liz Rice, and I'm on Twitter, I'm on GitHub, and if you want to come and hang out, I am on the Cilium and eBPF Slack, and also the CNCF Slack. So come say hello.
And we will put links to all of that in the show notes. Thank you so much for your time. I appreciate it.
Pleasure.
Liz Rice, Chief Open Source Officer at Isovalent. I'm cloud economist Corey Quinn, and this is Screaming in the Cloud. If you've enjoyed this podcast, please leave a 5-star review on your podcast platform of choice. Whereas if you've hated this podcast, please leave a 5-star review on your podcast platform of choice, along with an angry comment containing an eBPF program that, on every packet, fires off a Lambda function. Yes, it'll be extortionately expensive, almost half as much money as a managed NAT gateway.